Section 7.4, factored form of a quadratic function. So during this section, it might be helpful to have graphing technology, whether it's a graphing calculator, a computer where you can use Desmos, or an app on your iPad. The other thing you want to have handy is this graphing flowchart, which I put up on the website. It's a good thing to follow. Okay, what we're going to do is we're going to sketch the graph of this quadratic function and state the domain and range of the function. So this is given in standard form. That's when all your numbers are on one side and then just 0 or y is on the other side. But what I'm going to do before we sketch this is I'm going to just factor it because we're going to see something kind of neat when we factor this. So I'm going to get out my flowchart because I don't know how to factor. And it says here, first, I need to factor out any greatest common factor that is in each term. Okay, 2x squared plus 14x plus 1. I'm just going to look at it as an expression. And is there something greatest common factor I could factor out of everything? And there is. I could factor out a 2. I would get 2x squared plus 7x, that's a squared, plus 6. Okay, so I have followed it up to this point. Now it says, does this have 2 terms? Does it have 3 terms? Or does this have 4 terms? And I can see that this has 3 terms. Is it a perfect trinomial square? So in the brackets, x squared is a perfect square. That's what I'm looking for. And I'm looking if this last number is a perfect square. And then if this number is half of that perfect square. Or rather is the square root, twice the square root of that perfect square is what I'm looking for. Okay, so is 6 a perfect square? No. So we're going to follow the no. Is there a coefficient in front of the squared term? Is there something in front of x squared inside the brackets? No, there is not. So now what I'm looking for, what I'm looking for here, if my computer started to work, now it says I need to have the sum, I need to use the sum and product. I need to find 2 numbers that add to give me the middle term and 2 numbers that multiply to give me the last term. Okay? Oh, I lost all my work. Remember, I had 2x squared plus 7x plus 6. Okay, so I need 2 numbers that add to give me the middle term, that add to give me 7, and these same 2 numbers have to multiply to give me 6. It's pretty obvious that those numbers are going to be 6 and 1. So to factor, what I do is I put x plus 6, because it was a positive 6, and x plus 1. And there's going to be a neat relationship between our sketch and this factored form. So remember, it was 2x plus 6x plus 1. When I go to my graph, which I've already done, and this is a graph of 2x squared plus 14x plus 12. If you look at the zeros or the roots or the x-intercepts, you'll see that those are at -1 and -6. -1 and -6. So what they have done is they have taken each of these factors, they have set them each to be 0, and solved for x. And these are the roots. So the factored form really does tell you a lot about the sketch. It's going to tell you where it's going to cross that x-axis, which is pretty neat. Okay, the last thing it asks for is the domain and range. So from this graph, you should be able to see that domain is the x values. Any x value it can take on. Because this has a minimum, you can see that the y value would be everything greater than or equal to that point. Okay, so that would be the domain and range. Let's try another question. Okay, it says sketch the graph of the following quadratic function. F of x equals -x squared plus 6x plus 10. State the domain and range. Okay, so what we have to do is we have to follow the same steps. First of all, is there a greatest common factor? And I'm going to tell you this, anytime I can take out a negative, I'm going to call that greatest common factor. It'll make our life easier. So I'm going to factor out a -1. I am left with x squared minus 6x plus 10. Does this have 1 term or sorry, 2 terms, 3 terms, or 4 terms? This has 3 terms. Is it a perfect square? Is 10 a perfect square? No. So then I'm going to use the sum and product. So I need to find two numbers that add to give me -6, and those same two numbers must multiply to give me 10. Multiply to be 10. It looks like I have things like 5 and 1, 5 and 2. I have 10 and 1. Are there any numbers that exist that have these characteristics? And the answer is that doesn't exist. So we actually can't go about factoring this. So we're going to use something called partial factoring to sketch this graph. And what we're going to do is we're going to partial factor what we can. Okay? So if you notice these two terms, they have something in common. And you could factor out a -x. We could go -x. We're left with x plus 6, and then we have plus 10. Okay, so we abandon this kind of factoring, and we're going to use something called partial factoring, which is probably new to you guys. Okay, now what we do is we set each of these factors to what they're going to be. Or normally this would be a 0. Let's just bring our 10 to the other side. So what this means is that -x, we set that to be 0, so x equals 0, and f of 0 equals 10. Okay, and then we go x, this should be a -6. I made a mistake here. Sorry, guys. X minus 6, x minus 6. Now what we do is we say x minus 6 equals 0, x equals 6, and f of 6 equals 10 because of right here. Okay? So I'm saying x equals 0, and when I put that 0 in, I get a 10 on this side. So what that tells me is that tells me 2 points. It tells me that this parabola is going to go through the points 0 and 10, 0 and 10, and 6 and 10. Next, what I do is I can find the axis of symmetry. And remember, if I have 2 points on my parabola, the axis of symmetry is going to be halfway in between 2 points that have the same y value. So it's going to be halfway in between 0 and 6. So to find my axis of symmetry, I can go 0 plus 6 divided by 2 to find halfway in between. Well, that's just going to be 6 over 2, which is 3. So my axis of symmetry is 3. Okay, so now that I know where my axis of symmetry is, I know that my vertex is going to come right on that axis of symmetry. So I can sub in this value right here to spit out the y value of my vertex. And that's what I'm going to do right now. So remember, my original equation was f of x is equal to -x squared plus 6x plus 10. I'm going to put in 3. And I'm going to solve. So this would be -9, because it wasn't in brackets like that. It was just -3 squared. So that's -9 plus 18 plus 10. Solving this, I get 19. So my vertex is 3 and 19. Okay? So let's just double check that our work is correct. Let's actually graph this guy. I'm going to go here. And this equation was -x squared plus 6x plus 10. Okay, so remember we're looking for a vertex of 3 and 9. Sorry, 3 and 19. That looks really good. It said that our axis of symmetry was at x equals 3. Yep, that looks right. And this is parabola down, and we should have known it was parabola down from that y value, or sorry, from that a value, because it was -x squared. Okay, the other type question you might get is something like this. Determine the function that defines this parabola. Write it in standard form. Okay, so that means we can't have factored form. What I'm going to do is I'm going to notice these values here. X equals 4, y equals 0, and x equals -1 and 0. So that is my roots. Okay, so what we do is I know that this equation is going to be y equals a. I don't know the value of a yet. And then I'm going to have x plus 1 and x minus 4. So it's opposite to those roots. Okay, now what I'm going to do is I am going to um, pick a point on this graph, another point on this graph, to try and figure out then what my A is. And I see this pretty point right here. This is the point 0, 12. So what that means is when I put in an x value of 0, it should spit out a 12 for y. Okay, so 0 plus 1, 0 minus 4. Okay, and we're just going to do the work to solve for A. So I get 1 times -4. 12 is equal to -4a. Well, a must be -3. And if you think about it, that's starting to look right. A -3, sorry, I'm getting the a value. That makes sense because it's parabola down. Okay, so it makes sense that I should have a negative value there. Now all I'm doing is I'm subbing back in and getting standard form, so no factors. So y equals -3 is what we found, x plus 1, x minus 4. And what I've got to do is I've got to expand this. So this would be -3x minus 3 all times by x minus 4. So now I'm foiling, -3x squared plus 12x minus 3x plus 12. So I should get minus 3x squared. This would be plus 9x plus 12. So now I have that in standard form. Okay, here's something simple we can try here. We're just matching the functions with the parabolas. So which function is this? This must have a 0, it must be x, and it should be an x minus 8. So I know right away that this is going to go there. Okay, this one only has a 0 at 2. So I know it must be x minus 2 and x minus 2. The reason I know there's still two roots, or two factors rather, is because it's a quadratic. So I know that this guy must go there. And this last one has only one place to go, so it should have a 0, yep, and a minus 2. Looks good. So there's a couple questions like that. Okay, we'll just go over the key things to know. When a quadratic function is written in the factored form of y equals x minus r, x minus s, each factor can be used to determine a zero of the function by setting each of them equal to 0 and solving. The zeros of a quadratic function correspond to the x-intercepts of the parabola. If it has one or two x-intercepts, the equation of the parabola can be written in factored form using x-intercepts. If we don't have any zeros, they cannot be written in factored form. A quadratic function that's written in the form ax minus r, x minus s has the following characteristics. The x-intercepts are x equals r, x equals x, s. The linear equation of the axis of symmetry, we did this, is r plus s over 2. The y-intercept, and we didn't try this yet, is c equals a times r times s. So that if they ask you to find the y-intercept, you can do that. If it has only one x-intercept, the factored form is x minus r, x minus r. So you do have to write it twice if it only touches the x-axis once.